Okay. I don't know. Hello. That's not following me at all. Oh, yes, it is. Okay. Can you all hear me? Hello? 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 Alrighty, let's get the noise down, please. Okay, that setup takes way too long. Welcome to week 3 of COMP1511. Sounds like you're very excited for this lecture today. Yeah, me too. Bit of well, I wouldn't call it a warning, but today's and Friday's lecture is, I won't say full on, but they're really important topics, and there's a lot to get through. So just prepare yourselves mentally. We've got some snacks. So if you ask a good question or it comes up, someone does something good, I don't know, remind me and Gab will throw you some snack of your choice. I got a little goodie bag. And then welcome to those of you online as well. Let me know if anything stops working, audio, mic. It's a bit of a complicated setup, but I think we're good. All right. Someone in the lecture feedback form said they wanted the Copenhagen theme, so that's what we're using today. All right. As always, let's do a really quick recap of Friday's content. Sometimes just hearing the same information a second time, something gels a little differently or something clicks and it just makes sense because you've had time to sit with it. So these recaps are actually really important. So if you remember, we spoke about nested loops. That's how we started off the lecture. Nested loops are really useful, but they're nothing new. They're just a different way of using while loops that we've already spoken about. And really simply, it's when we put a loop within a loop. And whenever we do that, the inner loop's going to run its full cycle the number of times the outer loop runs. So it's a squared number of times, if that makes sense to you in your mathematical brain. The other way to think of it is by rows and columns. And therefore, two-dimensional data structures like grids or matrices or something like that are really well served by 2D arrays because you want to iterate through the first row and then you want to repeat iterating through each row for the column for the number of rows that you have. So 2D arrays and two-dimensional data set, I mean it's in the name, right? Two-dimensional are really useful. So here's a full little program that prints a 2x2 grid. Well, I guess 5x5, but 2 dimensions. And we looked at this code last week, right? Do we want to run through it again? Or is it okay with everyone? Show of hands if you want to run through it again. We can do a quick little run through online. We'll do a quick one, not as detailed as last week. Where's my mouse? Oh, I can use this thing, can I? Hello? Oh, okay. All right, I'm going to start skipping over this include standard I/O thing because we use it every single time and we should start getting familiar with it. But once again, it brings in the printing and reading libraries into our C programs. We have two constants here that we use this hash define to create. We're naming one rows and one columns, and we're assigning both of them 5. We spoke a little bit about why we use constants in certain cases. You're probably familiar with the concept. Constants are pieces of data that don't change their value over the life of the program. They're set in stone. So once this program runs, it's going to be 5, and we won't be able to update them. And the reason we use them in C is because they don't use any memory, so they're a bit more efficient than a variable. All right, Then we have the actual main function of the program, and it's not too complicated. The first thing we do is we set up a normal while loop, a counting loop, just like you do any while loop. So anytime we have a counting loop, we have to start our counter, and usually we set it at 0 to start, because we're going to start counting from 0. So if you're counting to 10 on your fingers, typically you start at 0, and then you get 1 and 2. This variable is tracking the counting. And we usually call it I, which stands for index. You could argue that that's not a good name in this case, but it makes sense a bit later on. Then we start our first while loop. And this is, again, really standard, typical stuff. While our counter is less than the number that we're counting to. In other words, keep counting, keep going, until we're done, until we reach our limit. And our limit in this case is that constant rows, which is going to be 5. So how many times will this first loop run? 5 times. 0, 1, 2, 3, 4, which is 5 times. And anytime we have a loop, the final component is we have to add 1 to that counter. Otherwise, we're going to just be stuck forever. You have to actually add 1 to the counter. And that is the basics of any while loop. What's different about nested loops is that, then we have the thing that we do in the loop, and that just happens to be what? To create another while loop. And to count another 5 times. And to do some quick maths, how many times will both loops run together? 25. 5 times for the outer loop, and every time the outer loop runs, the inner loop will run 5 times. Because it's counting until columns, which is also 5. So 5 times 5 is 25. Totally makes sense, right? So the question was, does the I++ and the J++ have to be at the end? Could it be the first thing that happens in the loop? Is that your question? The answer is it could be the first thing. However, it's not typical. And the reason it's not typical to do this is because sometimes we need to use I or J. And by incrementing it early, we're off by 1. So we want to know how many times has this loop run. The only way we can do that is by knowing the value of I. If we increment it too early, we think we're 1 ahead. So typically it's the last thing we do. It's a pretty standard way to set up these loops. Good question though. And that's it. And then the thing that we do inside the inner loop is print J. And J is the inner loop's counter, which is also just going from 1 to 5. It's going to 1 to 5 because we actually started at 1, because we want to print this grid, so we have to start the inner one at 1. If you want a more detailed breakdown of this program, remember we wrote it and I commented every single line in the previous lecture, so you can go have a look at that. All right, then we spoke about the main topic on Friday, which was custom data types, or structs and enums. So this was a new concept. So 2 custom data types that you can create. The first one is the struct. Really useful. You will use structs or variants of structs for the rest of your programming life. They've got lots of names: records, objects, dictionaries. It's all the same thing. It's a grouping of like data. So we define what the struct looks like. So in this case, we've got this Pokemon example. A Pokemon has an integer which represents the number of hit points. It might have the weight of the Pokemon, the name of the Pokemon, whatever the like data might be. And we can just say, yeah, I want this thing called a Pokemon, and it's got a bunch of different things within it. But we get one nice label for this group of data. And then we have enums, and enums are like, okay, I want this possible set of values to limit what something can be. So we spoke about days of the week last week. Months of the year is another example. Anytime there's a set limit to a range of values. In this case, there's another Pokemon example. Any questions on structs and enums? No? Online? No, okay. Well, that's good. So we're on to today's primary topic, which is functions. Super, super important. I love this lecture. I mean, it's kind of crazy that we've gone 3 weeks in intro programming and we haven't actually spoken about functions yet. So it's a really important lecture. Definitely one to wake yourself up for and pay attention. All right. We ready? We're feeling up to it? Okay, great. Great. Okay, so actually, you've used functions already. Who knew that? Some of you. Okay, good. I've said the word, right? I actually said at the beginning of the lecture. We had the main function. Did you notice that? So that's nice. We've already seen them. That's good, right? We're not going in totally blind. You've probably seen the main function. You've actually written functions this whole 3 weeks. You've been writing the main function. We just haven't really spoken about it. But you've also used other functions. You've called printf. You've called scanf. Any other examples? No, I don't think so. So you've used functions and you've written functions. So in that case, we're sort of done, right? There's more to talk about. So what actually are these? What's going on? Why are these useful? And how are we going to fill 2 hours on it? So functions are reusable blocks of code. That's really important. The main function is actually an exception because the main function is special. We can only have one and we don't call it. The computer calls it for us. So in that sense, it's not really a reusable block of code. So when we talk about functions, we're actually talking about all functions other than main. Let's talk about the really simple example with printf. Do you know what printf does? You know that it writes to the terminal, but do you know the lines of code that actually exist within it? No. Let's say there's 20 lines required in the printf function. Did you want to write those 20 lines every single time you want to print to the terminal? You got to find the output, which is standard output, flush the buffer. There's a bunch of stuff it has to do. We don't want to do that every single time. We just want to call printf. And that reusable block of code executes and we get to print to the terminal. And that's what functions are, and they're really powerful. They allow us to do common activities, give it a name, give it its instructions, and then we can reuse it over and over and over. And they're actually customizable, and that's because functions have input. So what's the input into printf? The thing that you're printing. Exactly. What's the input to scanf? The thing that you want to read. Exactly right. So that's really important. Functions have about 3 things. Input. We sometimes call these parameters. And you can probably figure out this is coming from the world of mathematics. Functions have input, a transformation, and output. I don't know, you probably do more maths than I do at this point. Is that right? Yeah. Good. They have actions. They have actions. So you printf, you call printf, what's the action commonly? Something gets printed to the terminal. That's the side effect of calling that function. Or in other words, the function had to do a certain number of things in order to achieve its goal. So it's got some things to do. And it's got output. Now, output sounds similar to side effects, right? Who's thinking that? So output, what I mean by output is the result of calling a function. So there is similarities to mathematics here, but there's actually a lot of differences. Mathematical functions don't have side effects. That doesn't quite make sense as far as maybe some mathematician's going to be like, you idiot. But functions take input, do a transformation, and return the result, right? Whereas, so do our functions. They have input, do a transformation, return a result, but they can also have a side effect. So if I have a function called add that takes two integers, x and y, what would the result be? The sum of the two inputs. In this case, is there a side effect? No. That's like a pure mathematical function. That seemed like it lost a few people. I think it'll make more sense when we see some code. So like most things in programming, we define functions and then we use functions. And the way we use functions is with a function call. That's how we actually execute functions. We have to provide it any necessary input, and then it will go off and run the body of the function. We can access the result of the function, and we can call our functions any amount of times we want, wherever we want. So let's look at some code, because I think those bullet points were getting a bit boring. So this code block at the top, that's a fully functional, a fully complete function. So let's break down the syntax of it. It's a really simple one, but it's useful. So I've got about 4 components here. Let's go through it dot point by dot point. So this first dot point is this int, which what I'm referring to there is this. You know what, actually, let's start at the second dot point, which is the name. So like variables, functions have identifiers. What do you want to name the function? The main function is named. I know, tough question. This function is named add. I decided the name, just like you decide the name of your variables. So that's the name of the function, and it's how I refer to it later. It's how I can call it. All right, the thing to the left of the name, there's always something to the left of the name. Question?
What if we name our function printf? Like, would that override?
Okay, so the question was, what happens if you name the function, say, printf? Now, the answer depends. If you haven't included standard I/O, I don't think there'll be a problem.
Okay.
Because you haven't it doesn't know about printf.
So is standard I/O kind of a library?
It is a library.
So,
yeah, standard I/O is a library.
Could we go, like, if, let's say, somehow we could access the files of C and we could change what printf does, can we do that?
So the question is, could you go off somewhere and edit what printf is doing? And yeah, absolutely, you could.
Okay.
Yeah. But another question could be, what happens if you name the function and some variable's already got the same name? In that case, there would be some error. So names have to be unique. Okay. So that's the name of the function. What have we got to the left there? So on the left of the name is the return type. Okay? So if I've got this function that adds 2 integers together, it makes sense logically that it's going to return what? An integer which will be the sum of the 2 inputs.
Like we write int in the case of add, what do we write in case of printf? Like,
We'll get there.
Okay.
Good question. The question was, what do we write in the case of printf? But we'll get there later on. So when you're creating a function, you need to first think, what should this function do? What should the result be? What's it computing, and what is the data type of that result? So do we have any questions on the return type and the name so far? Are we doing okay so far?
Yeah.
All right, great. All right, next we have the input. And that goes here. This is the input. The input or the parameters. So there's a little bit to talk about here. First thing is quite simple. It's basically what is required input for this function to do its job. So if I want a function that adds 2 numbers together, what's the input what must it be? Two numbers. So I have to explicitly say, I want one integer, and I want to call it x, and I want another integer, and I want to call it y. And these are just variable declarations. So you know, in your program in main, if you want to create an integer, what do? Int name. That's exactly what this is, comma separated for multiples. And that's really important because parameters are variables. They are variable declarations, accessible to the function only. And the really cool thing is that when we use functions, automatically the program puts into those parameters the value that was passed in, because it represents the input. We'll talk more about that later. In this case, there's two parameters. Could I just have one? Absolutely. I would just have int x, character, double my floating point, whatever. You could have 3, you could have 4, you could have 0. That's also common.
That's void, right?
Void, you could have put void there or you could put nothing.
So that's 0 inputs.
0 inputs. So you could have 0 inputs into a function.
Void do?
So void just means nothing, the lack of input. So when we write main, you notice we put void in the brackets because we don't have any input to main yet. We might at some points. All right, and that is that whole first line. Return type, name, input. This line is important. It's actually got a special term. Does anyone know what it is? Not the recipe. This line here, this return type, name, input, has a certain term.
Defining a function header?
Prototype is close. That's probably correct. But it's also called the signature. It's the signature because this unique combination of things, return type, name, input, right? And when I say input, I mean explicitly an int followed by an int, has to be unique within a program. And it sort of makes sense. Like, we don't care what it does, but this is the signature. It's such a nice term. I like it. It's the unique signature. Because signatures should be unique, right, between different people. That's why we use them. Say that again? Could you do int x, int y before the function signature? Well, if you declared x and y before this line, they wouldn't be within the function. In fact, they would be global variables. They wouldn't be in any function. So no, they would not be parameters. They have to exist right in this special spot. All right. Now, next we have something. We've spoken about this a couple times now. What do these curly braces represent? A block of code. A sequence of code that executes when this function executes. If you think about if statements, if the if statement's true, the block of code runs. When this function is called, the block of code runs.
Sorry, just to clarify that question before. The two integers we have to define for the first time in this function.
Any input, any parameters into a function have to be defined within the braces of the function.
So in this code, this is the first time you mentioned int x and int y.
Okay, the answer is a little bit more complicated than that. You could also have an int x in main. They would be different. So we haven't really spoken about scoping yet, but the quick takeaway for those of you who have the capacity to think about it, blocks of code have their own scope. These integers are in the scope of this function, so they can exist separately to any other x and y.
So the integers in the other one would be
Exactly. What the person said there was that the integers in main have their own scope, which is true.
I was going to say, if we define this function, you have to define it inside the main function.
We'll show you in place of a bigger program in a second. The question was, where do we actually put this? Okay, there's one more component here, and that's this line here. Now, there could be multiple lines that happen before this that we don't care about. This return is important. What do you think it does if you're not familiar with it before? Louder?
Can you just repeat?
What is this? What do we think return might do?
It returns the value and it stores it in the function.
Okay. If we've said this function has to return an integer, right? At some point, I need to be able to describe what integer value I want to return. Oh, there's the keyword, return. It's the value that the function will return. And the way it works is it comes across the return keyword, and it says, evaluate what's on the right side of me, and then that's what I'll return. In this case, it's x plus y. So it gets the value of x, it gets the value of y, adds them together, because there's a plus symbol, and then returns it. Did I answer someone's question? There was a hand. I think I answered it, maybe. So that's the anatomy of a function. How do I call a function? So this is the defining a function, like we define a struct. How do I then use it, call it? It's actually really simple, which is nice. We simply use the name. Where's my mouse? Where's my mouse? Yeah. We simply type the name of the function, add, brackets, and then these are my two integers that will map to x and y. These are my input arguments, we call them. Really important is this third point. We must pass in the correct sequence of arguments of the correct data type. This function expects two integers. I have to give it two integers. If you don't, there'll be chaos. All right.
In Python, we can arrange the sequence of the variables, for example, but we have to declare for example, y is 5 and x is 2. Can we do it in C?
I think the question was, in Python you can have default values into parameters, is that right?
Yeah, we can declare y is equal to 5. And
When you're defining the function, like here.
When we call it.
Oh, I see. There's no named variable parameters in C, so you can't do that. The question was about a Python language feature, but it doesn't exist in C. All right, this is a fully functional program, and this is where we place these components. So we do not, I see this not very much, but I do see it sometimes. We do not define functions within main. Right? They have to be accessible to the whole program. Now, you can define functions within main, but don't do it. It does work, but it limits the scope of that function. There's probably some esoteric edge case where it's valuable to do so, but I'm not a good enough C programmer to be able to say what that might be.
So like the line in which we write the standard IO, would that be up or down?
Above.
Above.
So you'd put hash include standard IO above it.
What if I define the function first, and then I name it printf, and then after that I do standard IO.
So okay, the question's a little specific. The question, okay, it's a reasonable question. Let me answer it. The question was, what happens if I do like I define my function here, then here, like in between the two functions, I hash include standard IO. will there be a clash if I name this function printf? And the answer is yes, there will, because a hash includes, anything with a hash in front of it actually happens before compilation. So it'll include it and then try and compile it, and then there'll be an error. But it's actually a useful fact to know. Anything with a hash include, hash define, there's others, they happen before compilation.
So it's not a line-by-line thing?
In that case, no. Yeah, okay. We're getting off track. We define our functions outside of main in the top level sort of scope, and then we can use them inside of main. So what's add going to do here? It's going to add which two numbers? Exactly right. And it'll get the current date. There's a bit of murmuring. What's the vibe of the murmuring? Are we comfortable, not comfortable? Can we do maybe a quick YouTube poll? Is that okay? Just like, how are we sitting with functions so far? And how are we going in the room? Who's happy with all of this so far? Who's like, I think I'm okay, but let's do a demo and then that'll sit a bit better? No? A couple of people. And who's like, nah, you've lost me? A couple of, that's okay. All right, but a lot of you are still with it. Let's wait for the poll. Stay hydrated. Yeah. You can't overload functions in C. I won't repeat the question because it's a bit... It's annoying. It'd be nice if we could. Sorry. I don't mind the room noise, but it really picks up on the mic, and it's really annoying for the recording. So I'm sorry. We'll do it. We'll make noise during the Kahoot.
You know how you define in X and in Y, so it's going to add in X and in Y. Does that mean because you use year, born, and age, can I apply any variable to be in X and apply any variable?
Absolutely. Whatever the input into the function. Okay, you guys have to remind me to repeat the question. It's a bad habit. The question was, we've defined the function's input to be X and Y, int X and int Y, but I'm calling it with year, born, and age. I guess the question is like, does that hold up? And the answer is absolutely. I can call it with variables. I can call it with integer literals there. Doesn't matter. In fact, that could be an expression. I could call add 2 plus 2, comma, 2 plus 2, which will be 8. We can do whatever we want. Yeah, okay. So the question is, can I call add within the body of add? Can I call a function within the body of the function? This is a concept called recursion. You can absolutely do it. We do touch on it at the end of the course if we have time. It's absolutely possible. We don't require it in the... I won't say we don't require it. It could pop up. There's certain types of problems that are nicely solved with recursion. Did we get a poll? Oh, there we go. Got it, demo. I'm getting their demo. Awesome. All right. One more thing before the demo. Now, in this example here, there's a, I don't know if you'd call it a problem. This compiles and runs absolutely perfectly. But you might be asking, Jake, here I called add, I added two numbers together, right? Where's the result? Where is it though? It's not here, right? How do I access the result? And the answer is, it gets, where's my mouse? It comes out of the function call. And so here we would take that result. That's not correct, by the way. That should be current year. Don't at me. Where's my mouse? Again, why is it really? There we go. There we go. And that will store the resulting integer in current year. All right, and that's pretty much how we define and use functions. So who wants to see a demo, write some code? Yep. Then we'll do some Kahoot. Whoa, go away. Oh, that's cool. Okay. Now, last week, VLab was really, really slow for me. So I'm going to write in VS Code, but I'm going to SSH in. So the code will still be public. You'll be able to access it, but it won't look like VLab. But it was so slow, I can't do that again. Oh, it loaded it for me. That's nice. Okay. Where's my mouse? I might switch to a light theme. Can you all read that? All right. And you got to bear with me a bit because I can't see the code. I need to. All right. All right. I think this is the last week that I'm going to be typing out the C boilerplate with you. I think for now on I'll sort of just generate it. But it's week 3. We're still starting out a little bit, so let's take our time together. First thing, we usually want to include standard.io.h. I'm also going to turn off Copilot, that I definitely don't use. Excuse me. So we include standard.io. What's the next thing we do when we're starting off a C program? Yep. And now you know that this is a function definition. It's got a return type, a name, input. In this case, there's no input. And a block, and a body.
That's why we write return to.
That's why you need those 3 components. It's why you need the int, it's why you need the void. Now it makes a bit more sense. And now, because we're saying that main returns an int, what do we have to have here? So a good question might be, Jake, why does main need to return an int? And we did speak about this. It's because the main function needs to indicate back to the operating system whether or not the program as a whole successfully completed or not. And we use an integer to describe that. And 0 typically means no problem. All right, so that's our function, our main function, yeah. So let's write a program. What's a good function? What's a good function? Adding is a bit boring. Any ideas?
You can ask us our age and then tell us if we're old.
All right. I like that. A function with some input. I like that. Yeah, nice one. I like that. Okay. So we're going to make a function which asks the user's age. And why is this working? And prints. Oh, we could do age checker. Yeah. Do you want to do the minimum age checker again?
No.
No.
If you tell us if you're old.
If you're okay, fine. I don't want to hear the answer to this, but and print some messages. We'll just say that for now. All right. So the first thing. So okay, we're writing a function that asks the user for their age. Now, you might be thinking, Well, the input then must be the age. But actually, if we're going to use scanf, then that needs to happen within the body of the function. Right? But what might the function's input need to be? If we're going to... Oh, actually, no, that's not a good example. It'd be good to do a function that needs input. So maybe let's do something else. All right, I have an idea. You know, does Subway still do the 10% discounts? I heard they got rid of it. Is that true?
Free cookie.
Free cookie if you're a student.
No,
You have to fill a survey.
Oh, no. But don't they have a 10% student discount? Nothing? Assholes. All right, let's write a function that calculates a discount depending on the user's age. At Subway, let's say. Do people like Subway? All right. So here's how it's going to work. And for now, I'm just going to tell you, I'm planning this out, I'm designing it, and we'll describe it and we'll write it together. So it's going to accept the total cost, accept the user's age, return the discounted cost. This is what we're going to write. So whenever we write functions, it's important we know the plan. What's the input? What's the goal? What's the output? And we know these three things here, right? So what should I start typing? What's the return type of this function going to be? Double, because costs are floating point. Int is not that far off, but you were thinking too inty. Okay, double. What are we going to name this function? I have a whole lecture deck, if we get time, on naming things. I find it so important. None of the examples you gave were wrong. I would call this maybe calculate. Now, here's an example of where you could pick a bad name. Is this calculating the discount? Who thinks it's calculating the discount?
Discounted cost.
It's calculating the discounted cost. So you want to be specific with your names. Because if someone else is reading your code, you don't want to give them the wrong impression. So it's calculate discounted cost. I like that function there. Now, some people really hate long function names. I think you're misguided. It doesn't hurt. If it's a good name, it's better to have a bit longer than, This isn't 1960 where we had 40 character wide monitors. Everyone's got 4K bloody Retina HDR plus, I don't know. All right. What's the input?
total cost and age.
What's the first parameter we want? We can pick, but let's say the age. And the age is going to be an integer. And we need the cost. And it's going to be a what? You got it. Too easy for you guys. That's it. That's a function definition for my function. Is that following me still or not? This thing needs to work way harder. Whatever. All right. Remember to keep the noise down while we work. All right. What do we need to do in this function to calculate the discounted cost? Well, one of the problems here actually is that you don't know the business rules. You don't know what we're trying to do. We're coming up with it as we go. One thing we can say is if they're below 18, for example, maybe they get a 20% discount. Maybe if they're above 65, they get a seniors discount. And in the middle, maybe you get no discount. Something like that is reasonable, right? So to do something like that, we need to pick a tool from our toolbox. The if statement. Yeah. And we can do whatever language features we want within functions. So if the age is less than, do you get it if you're 18?
Yes.
All right, deal. So we want less than or equal to, right? This is conditional expressions, Boolean expressions from earlier. Less than or equal to 18. How do we then take 10% off the cost?
Cost equals cost minus 0.1.
Well, what do we need to reassign cost? So we don't need to do cost equals. What do we want to do here? Return. And what will we return? Yeah, that's better, yeah. Cost times 0.9, exactly. Yep. Where's my mouse gone? All right. Is that better? I think it's better. So we take 90% of the cost and return it, which is a 10% discount. Quick maths. Now, what's the other condition we want to check? If they're over 60, again, the noise, we'll have a break soon, I promise. Keep the noise down. What do we want to... Okay, so this student has made a good observation. Could we use or here to say, if they're less than 18 or greater than 65, give them a 10% discount? We could do that, if it's the same discount, of course. You could argue, maybe I'm getting, yes, the answer is yes. I might be getting a bit too 1531 on you here. It might be better to separate them, because in the future, does that make sense? Could probably be better? Else if, love it. Maybe they get a 15% discount. Style according to our style guide. Style is subjective to an extent. Some things are blasphemy, but typically the way it works is your software shop, lab, company, mega corporation will have a certain style guide based on the project. We have one that we give you that's quite, I think it's based off Google's, but you basically do whatever your senior developers tell you to do. Now, this program looks good. There's no squiggly, scary underlines. There's actually a significant problem with it. And does anyone know what that is?
Not determining the default cost.
Okay. What happens if the user or the person, the shopper, is 25? Hold on. Before we get to the solution, I want to explain what the problem is. Because this, in fact, will be a compilation error. If we compile this, there'll be an error. It's not that the program doesn't care that we didn't have an if statement in between. It doesn't even really know. The problem is that not all paths of this program have a return statement. But functions must always return something. You could do else return 0, or I could just say return cost. It's actually the same thing in this case. But it's an important note. Every possible branch of a function must have a return statement.
We have to, well, not we have to, but should we have the return cost in else?
Okay, the question was, should we have an else here? And I think the live stream's it's back. We're okay. The question was, why don't I have an else here? Could you put it? You could put it in an else, but it's the equivalent. Doesn't matter. It's going to run no matter what, just like the else statement. Guys, the noise, sorry, it really does pick up on the mic.
Suppose that your age was 17, so one time you return 0.95 and then another time you return 5.
Can you repeat that again?
So suppose that your age was 17 and it is less than 18, you are returning twice.
Oh, okay, great question. The question was, what happens if your age is less than 17? Will you return twice? Because it's less than 18, so you'll return here, then the program will continue, and then return here. What? Did you just hit him? You're okay? Do you need me to call the... You're right? Cool. Call the police? All right. You've raised a great point that I actually have omitted. Return is special. It exits the function. The function will not continue to execute. It's returning the function. It's returning from the function, and it's returning to the caller. So in this case, it'll go back to main. So it won't continue running. All right. Why don't we do this? Let me just copy that. Let's also do... What did I forget to do? Prompt, yeah, never forget. Now, can I give it the cost and then the age? Why not? Because it's age and then the cost. The order matters. In this case, you can see it doesn't even warn me. So the order matters. Now, this is going to return a result, right? Which will be the discounted price. People are busy typing the program, so I'll give it a second. I could return it and store it in a variable. I could also just do this. Yep. Let's take a minute to look at this. Is this magnifying thing any good? Or is it distracting? I can change it. We have the technology. Highlighter? Ooh, I like that. That's cool. Still distracting, probably. So this will go off, call the function, calculate the new cost, and immediately pass it into printf. And we can use functions this way if we don't need to store the result. Who's happy with this program? Any issues with it? Should we compile it and prove me wrong? Oops. No errors, that's good. What's the customer's age? How old are you?
17.
You're 17? God, this is so young. And how much would you spend on Subway on your average order? $15? Pretty, 0.75. make that nice. And that's a function. And that's really nice because we can call it again, call it again, call it again. In just one line of extra code, I get to run 6 lines of code for free. That's pretty nice. Any questions on functions so far? Online? I am -1 years old. Do I still get a 10% discount? According to our logic, you will.
Just a quick question. Usually with the printf, you know how you have a variable, you have a comma and you have a variable. Is that calculated discount cost like a variable, or would you assign it to a variable, or is it not really?
Yeah, so it's a good question. The question is usually we give printf a variable after the comma, right? Which is true. We usually, so far at least, we've given it a variable. In fact, it doesn't need a variable, it needs a value. We've just been getting the value out of a variable, okay? In this case, we're getting the value out of the result of this function call. It's the same thing. But there's no memory here storing it. Well, there is, but let's not get into it.
So just to follow up, if we wanted to access that value again, instead of using a variable, would we just use that? So
Great question. What if we want to access the value again? We can't. We can't. We've not stored it. We've not stored it. We've used it and it's discarded. Unless we assign it to a variable and then we use the variable.
So in the function before, if you define int age and double cost instead as int x and double y to
Okay, all right, that's actually a great question. Thank you. Guys, noise. I promise we'll break soon. If you're paying attention, you'll notice there's age here and there's cost here, and there's age here and there's cost here. Now, does it need to be that way? No. This could be like that. That's going to work just fine. But here's an extra note to that. And if you're thinking, wow, how the hell did Jake do that? That's pretty cool. I don't know. This age is not the same as this age. They are different pieces of memory. Because this is scoped to this function, and this age is scoped to this function. Another way of saying that is when variables are declared, they belong to the parent's block of code. That's scope. Scope is important. It will throw you off at some point in your programming career. I promise. All right. Who's ready for a break? All right, good. 5 minutes, come back. I'll get the Kahoot ready and we'll Kahoot. Is my camera going to be in the way there? Or is it okay? It might be in the way. The camera. Maybe there. John Lennon. Got some Beatles fans in the house. Ooh. All right, let's get to 200 and then you will never see more creativity than Kahoot names. Has it been 5 minutes yet, do we think? A couple more minutes? You missed the final bracket on your... Who is that? Alright, we got a lot of players today. Okay. We ready? Yes? Anyone not ready? Don't take photos of this. HR's going to call me next week or something. They're still coming in. The final bracket doesn't fit. Are we ready? They're still coming in hot. 250 or we're good? I think we're good. All right, I'll read them out. I'll move my... Oh, that's a good spot for it. Which of the following cannot be used as an identifier? Ooh. Is that correct? I think that's correct, yeah. All right, brutal. float, remember C is case sensitive. So float lowercase would be reserved. Uppercase is not going to be reserved. But you can't have special characters like a single quote within an identifier. The other two are obviously okay. Does that explain it for those of you that got it wrong? All right. Find the output. Well done to those of you who caught the little gotcha. Let's have a look at it. You saw if and you're like, oh, I know what that is. But you're spotting it now. All right. This actually does this does come up sometimes. It is a common mistake. This semicolon here terminates the if statement. So this will evaluate to false, and then it does, and then that's it, it's over, and then this will execute. It's missing, so if there was no semicolon here, it actually would work, but really you should have the braces as well. So that'll run, then that'll run, and then it returns 0. Got to pay attention. That's spice. Which special characters can be used to separate two parts of an identifier? Whoa, that was quick. That was, okay, too easy. This is so lame. I've seen Ice Spice. What is it? Is it a singer? Is it? Yeah, okay. Find the output of this program. I explicitly called this out last lecture. Remember? I explicitly spoke about this. Struct definitions don't have values. Yeah?
It's also %f instead of %ns.
That actually is not an error. Yeah. So you got lucky if you got away with that. You got lucky. That's not the problem. That will actually work okay. It'll print out a short float. So less decimal points. The problem is structs don't have values. We said this. We're defining what a struct looks like. It doesn't make sense to give it values. The user of the struct over here needs to give it values. So this is a compiler error. It's not valid C syntax. Yeah, long float is just more precision on a float, so that actually works. Who said error because of the F? Oh, not that many people. Okay. All right. Actually, majority of you got it right there, so well done. Oh, bye, Ice Blast. Two more. All right, remember, so x is not greater than 10, right? So it won't run this block. Now, if you don't have curly braces, these are single line blocks. We don't use them in 1511, but they are valid. It is greater than or equal to 0, so we add nothing. And then the rest are else statements, so they won't run. So this is quite straightforward. A lot of people put blue, so 0. So what did that do? I guess that is that you thought that this was true. Is that what some people did? Who put 0? Why did you put 0? It's not equal to that. That's right. Okay, yeah. Two more. Can you read that? You might need to look at your phone. Did you guys catch it? Caught it? Who caught it? Put your hand up if you caught it. There's 9 of you. Were you all online? Who put true? Why did you put true? Hold on, wait. You guessed? Oh. God. You put your hand up? I told you. You see? Do you see how easy it is to miss over that? All right. In C, when you assign a value, I can't quite remember, but it returns a truthy value. So x will be assigned 10, and that went A-OK, so that's true. Therefore, the block runs true. You can go and compile it and see for yourself. All right. Ooh. Really creative names on the top. All right, last question. Any C program Come on, everyone. Which function must every C program have? Main. If there's no main function, there's no program. Now, you could get really tricky and be like, Jake, I've been programming C for years. I could have a library with no main and no function. In which case, yeah, that's a library, not a program. Come at me. It's getting cut off a bit. Jod Gaius, AR, well done. And is it going to be P? Probably. D! Well done. What a turn of events. All right, come down if you're in the room. Is that you? Which one are you? AR. Do you want a card or do you want a snack? All right, pick your card. Who else won? Someone there won. Yeah. Show the camera. Oh, you gotta. I guess you gotta show me. What is it? That's not real. Pro Pass. That's cool. Is that like a? Yeah. Anyway, enjoy.
I was third. Yeah.
You're who?
Yeah, I scraped it. I was third.
I can't see it. Hold on.
It's all right. It's like, yeah.
Oh, that's you. You gotta show the camera.
Oh, sure. Is that
Maybe I'll hold it. What is it?
right? I don't know what it is.
Neither do I. A banet?
Yeah. Yeah.
Card or snack? Card or snack?
Card. Which one's bigger?
I don't know. That looks awful. That's not a Pokemon. Dusclops. Is that a good one? I don't know. Congratulations. Well done to our winners. But what's most important is that we learned something. Yeah? No. We just want to win. All right. Let me just restart this. Someone, Gab was saying, can you read the slides okay? Do they look okay? All right, they look okay. Okay. Alrighty, we got a bit more to get through. Let's keep going. Whoops. Low battery, be quiet. Hold on. Oh no. All right, this might be a useful sort of cheat sheet for you. Something I see a lot, actually, is confusion between parameters and arguments. I hear seasoned software developers confuse these two. There is a clear difference between them. Parameters are the input at the function level, right? So int x, int y in our example from earlier. Those are the parameters. They're the variables that we use within a function. Arguments are the values that we pass into the function. Does that make sense? There is a clear definition between the two. So this is you might want to keep a reference to this little cheat sheet on the terminology. The rest are pretty straightforward. Return type is the type that gets returned. The result is the actual value that gets computed or evaluated and then returned. And then return is the keyword we use to return something. All right. So that's functions. Once again, we're introducing, there's sort of an asterisk here, sort of a new concept called procedures. The good news is that they are functions, so there's nothing really new coming. So it's not a real thing in C. It is actually a real thing in other languages. But I think it's a very useful way about thinking about functions. So what are procedures? So not all functions have to return a value. We said this earlier with the side effect thing. And we also said that this is what differentiates us from, say, mathematics. So some functions just do something. Now you've used an example of these. What's the example? Main does return something. Scan actually does return something. Yeah, so it's not scanf, it's the other one. Printf. Printf does something. It doesn't return something. It prints to the terminal, but it doesn't return a result. So that's an example of a procedure. It's a void function. Typical C programmers will just call these void functions. It's a function that returns nothing or returns void. and they have a side effect usually. So here's a really simple example. If I say you at the back to shut the door, what will the side effect be?
There will be noise.
There will be noise. The door will shut. I like you bucking the system though. Look at that math formula. Cool, good for them. If I say you to open the door should open if you do what I say. Now, I might hear the noise, I might see the door shut, but I don't actually have a result, right? But if I ask you, someone here, to check is the door shut, can you do that for me? This door? I'm not looking. Is the door shut? There's a result. He said yes back to me. That's a function that returns something. But if I say to you, can you go open that door? Do you actually want to do it? Go open the door. Now I can just live my life. The door will open. That's the side effect. But he doesn't have to say anything to me. That's a void function or a procedure. You're done. Thank you. Thank you for opening the door. So he didn't have to give me back a result. Does that make sense?
Yeah.
And the good news is the syntax, they are just functions. There's no difference. The only difference is, well, where's my mouse? The only difference is they always return nothing, so they return void. Void means nothing. If you know what the word means in English, you know, a void is like a massive unending hole, right? Or the void of, I don't know, probably some philosophy. It could be confirmation. Yeah, that's a good use of a function. But something will come back and the type will be whatever's here. But some functions are actions, side effects, and I call these procedures. But it might be a me thing because I first learned programming in a language very similar to C that had procedures as part of the language. Anyone know what language that is? You'll never get it. No, not Fortran. I don't know, although it might have procedure. If anyone gets it, you can have a snack. What'd you say?
C++?
No.
C sharp?
No. I said it's like C. Anyway, no, it's not Java. If you guess it, you can tell me later. All right. So we would call these procedures, but they are just functions. Actually, that's it on procedures. That's all it is. We could write one, but if we get time, we'll do a different demo. Most C programmers don't have a word for these things. They just call them void functions. I just want to make that clear. Any questions on them on the chat? Pascal, yeah, good job. They got it online. Did someone say Pascal? Oh. Too bad you can't have a snack, Andrew and Cockram. All right. Okay, a few more things on functions and procedures. This applies to both. Order matters. Functions must be defined before they are called. Okay. So what this means is if I go say, I'm gonna throw a tantrum. So order matters. So we have two solutions to this problem. Is that still readable? We have two solutions to this problem. One is to simply define all functions before they're used. So put the function above where it's called. It's that simple. Like this is valid. Now you might think, well, I'm just going to do that. But you might have more. You will often have 5, 10, 15 functions in a file, right? Because that's one function, but I could write another function. You know, int check. I'll just say do something here. And now if this, we might call this function within this function, right? Like first, check if the age is valid. If not, return or, exit or throw an error. Which means right now you can see the dependency can get a little complex because this has to be before this and this has to be before main. And what if there's functions that need to use both of these? Where does that one go? It's all possible to do. You could lay it out nicely. But there's another solution, and that is by writing forward. It's called forward declaration or using function prototypes. And simply what we can do is we can say, let me just comment that out for now, is we can say to the compiler, hey, I'm going to have a function called calculate discounted cost. That's it. I'm going to have this function. Trust me. Trust me. And so when C comes through line by line, it comes across this, and it goes, oh, okay, there's a prototype exist. And we call that benefit of this is that the order of the functions don't matter anymore. In 1511, we get you to do forward declarations for all of your significant problems. So the assignments, most of the labs, all of that stuff. Does that make sense? You literally copy the signature, paste it at the top, and put a semicolon at the end. Now, one quick piece of advice. This will happen to a lot of people. You will go and edit this function, and you might say, oh, I now need to know something else. But what's the problem here? Your function signatures, you have to go and edit the forward declaration again. You got to keep them in sync. There was a hand somewhere?
So if you do this, the order of the functions doesn't matter?
Correct.
So like even if you call check if age valid after double calculate discount cost, but then you call it inside that, there's still.
So the question was, so if we forward declare you have to forward declare all the functions. So I didn't forward declare this one. You would want to forward declare all of them. Not the main function, that's okay. And then the order, you can call them in any order before or after they're declared. Yeah. All right. So a bit of advice from someone who's been programming for maybe longer than you, maybe not. A lot of you will understand the concept of functions, the syntax of functions, and how to write it. You will follow along, you probably followed along with me, and you're like, yeah, that compiles. And then you'll go off to your assignment, and you'll get stuck. This will happen. And I think the problem is that you've understood the mechanics of the functions, and this happens to all concepts in programming, but you haven't thought how to think about them, how to design them, how to plan your programs. So it's important to think about it a little bit. Here's the way I think about it. The first is, in fact, I think there's a dot point missing. The first thing I would be thinking is, what is the job of this function? What does it need? What's my goal here? One thing us programmers do, I'm guilty too, is that we love writing code. It feels good. We feel like hackers. But we haven't thought about what we're trying to do. So number one, think about what you're trying to do. Number two, in order for this function to do its job, what does it need? If I ask you to check if a door's shut, what do you need? You looked at the door, but there's 2 doors. There's 3 doors, actually. What do you need to know to do your job? What were you going to say? You need eyes, absolutely. So you need to be able to do something, but you need something else from me. Which door? Where's the door? Same thing. Which door? Right? So that would be input. What does the function... If I ask someone else who's looking at me, you... look away. If I ask you, what's the weather on a particular day? That's your job. What do you need to know from me? The day. And where. And where. Great. So certain jobs require input. This makes sense. If you go ask someone to do something, ask a sibling or something to do a chore, they might need input. Which chore? When do you need it done by? There's certain information that's required. All right, what should it be named? That's a bit more straightforward. If your job is to check the door, I'm not going to name you like add two numbers together. That would be really confusing. It would be valid, but confusing. And what should it return back to me, if anything? And am I rewriting code that could be turned into a reusable function? That's another important one. If you're writing code and you're writing, say, 3 or 4 instructions over and over again in different places, an alarm bell should ring whenever there's a concept, this is something I talk about in 1531, software engineering. There's a concept called DRY. Does anyone know what it stands for? Don't repeat yourself. If in code you're repeating yourself, that's a red flag. If you've repeated yourself, turn it into a function. Or maybe turn it into a loop, depending on the problem. So functions are really important. They do change how we think about code. There's a concept in object-oriented programming called functional decomposition, which is a fancy word for saying we want to break our problems into the smallest reusable chunks. And functions allow us to do that. So when you come across useful repeated functionality, make it a function. I think I got this slide. There was something else I was going to say before that though. Have I forgot it? Have I forgot it? Is there anything else to add on functions that you would say? We did talk about it a bit. I think we'll talk about scope more in detail when we talk about scope. Gab? Okay, all right, yeah. Whoops. We did talk about this a little bit, but so for example here, we can call other functions within functions. So calculate discounted cost runs. We might want to check if before we even calculate the discount, someone mentioned actually having a negative age. We might want to do that, right? If age is less than 0, return 0 for false. And then I can say, if the age is valid, then we do all of this. So we can call other functions. This isn't quite complete, by the way, but we can call other functions and we can go many, many layers deep. So that's another good point. Function call. We don't care about the names of the input, right? We did talk about this, but what we're really getting out of age is the integer value. What we're getting out of cost is the value. Those then get passed in, the names are irrelevant.
If one of our functions that's not main had something like print and we executed the mark main, would it print to the terminal?
Can you repeat that again?
So if one of the functions has print or
Yep.
scan in it, will it execute that?
Okay, I got it. I got your question. So the question was, is this going to print before main? Is that your question? So the answer is no. The program always starts at main and executes line by line. When I said it goes top to the bottom checking, that's just checking that everything's in the right place. It's a different process. Good question though again. All right, I think we're ready to call it. I've this addition to my lecture. I added this last night in just a flurry of inspiration. Has anyone seen this before or heard of the concept? Anyone? I thought it came from physics, but apparently before physics it actually did come from computing. Maybe anyone online? So it's the 0-1 infinity rule, and it's something I like to talk about when I talk about software engineering. So again, it's a bit more of a 1531 thing, but I think the core idea is relevant to all of you. So if you're writing code, all right, you're writing a program, and you might think, this is a software engineering good practice tip, and you might think, I will need a function to check the age. I will need it, but you don't need it yet, right? that means you've got zero need for it at the moment. Do we all agree so far? Therefore, don't write the function yet. Write it when you need it. So that's the zero case. Then you're writing some code and you need to check the user's age in one place. You've got one need for a bit of code. Should you make it a function? My advice would be don't over-engineer it. Don't make it a function just yet. You might only ever have one need for it. And therefore, it's probably not good to clutter your program with a function. However, as soon as you have two or more, then you're in the infinity case. As soon as you get the second need for a function, for a bit of code, then make it a function and reuse it. This idea exists in physics. I don't quite know the anecdote very well, but it's something like there can be nothing of something, one of something, but because the universe is infinite, as soon as there's two, there's infinite. Does that make sense a little bit? Anyway, it's a little thing to keep in mind when we're writing code. Please give us some feedback for the lectures if you'd like. Otherwise, thank you so much for today, and I'll see you on Friday.